There's a specific silence that falls over a cabin the moment the plane starts shaking. Everyone pretends to keep reading, but nobody is. And somewhere in that silence is the quiet realization that we've all agreed to sit inside a metal tube going 500 miles an hour without really knowing why it occasionally shudders like it's having second thoughts. That shuddering is turbulence, and it's far more interesting and far less threatening than your nervous system believes. The core misunderstanding is that we treat air as nothing. Empty space we move through. But air is a fluid, and it behaves like one, with all the currents, eddies, and general chaos that implies. The atmosphere is less a calm ocean and more a river with rapids you can't see, and an aircraft is just a very expensive object trying to hold a steady line through moving water. Turbulence, technically, is the breakdown of smooth, laminar airflow into chaotic, disorganized motion. Physicists will tell you turbulence is one of the last genuinely unsolved problems in classical mechanics, which is a polite way of saying we can fly through it, but we can't fully predict it. We've mapped the ocean floor and we've sequenced the genome, but the air outside your window is still, mathematically, a bit of a mystery. There are a few distinct varieties, and it helps to know which one is ruining your day. The most common is convective. Sunlight hits the ground unevenly, the ground heats the air, and the warm air rises in invisible columns called thermals. Gliders and birds exploit these deliberately. Commercial aircraft just blunder through them, which is why bumps tend to cluster over hot terrain on a clear afternoon. Then there's mechanical turbulence, which is what happens when moving air meets something solid, a mountain range, a city, a ridgeline, and gets shredded into disorder on the far side. The air was flowing in a perfectly reasonable line, hit an obstacle, and is now tumbling downstream in a state of aerodynamic disarray. This is why approaches in the mountain airports have a reputation, and why pilots there earn their salaries. But the variety that actually unsettles the people flying the plane is clear air turbulence. No clouds, no storm, no visible warning of any kind. One moment, the seatbelt sign is off and the crew is pouring drinks. The next, the aircraft drops into air that has no business being that violent. It is functionally an ambush. It congregates near jet streams, the narrow ribbons of wind at cruising altitude that can exceed 200 miles an hour. At the boundary where that fast river meets the slower surrounding air, you get wind shear, layers of atmosphere sliding past each other at wildly different speeds. The shearing tears smooth flow apart, the same way two currents meeting in a straight produce a churning, unpredictable seam. Here's the uncomfortable part. We largely can't see it coming. Onboard weather radar works by detecting moisture, which makes it excellent at painting storm cells and useless against dry, clear air. So clear air turbulence is effectively invisible to the instruments meant to warn us. Detection still relies heavily on pilots radioing back reports after they've already flown through it, which means that, on some level, the people flying the plane are only slightly more informed than the rest of us. None of which means you should be afraid, and I mean that in the literal sense, not the way the captain means it. A modern airliner is engineered to survive loads far beyond anything the atmosphere is likely to produce. The wings are stress tested to bend several feet upwards before they fail, deliberately flexing the angles no flight will ever demand, and photographed doing it. The airframe is not the fragile component in this system. You are. Structural failures caused by turbulence are exceptionally rare, and almost always involve older aircraft in genuinely extreme conditions. The actual injuries happen inside the cabin, to people and objects in motion. Unrestrained passengers meeting the ceiling, a laptop becoming a projectile, a cart of hot coffee redistributing itself across 3 rows. The plane will be fine. The people who ignored the seatbelt sign, less so. Which is the entire reason the crew treats that sign with the gravity of a legal document. It isn't theater, and it isn't liability paperwork you're meant to ignore. When it comes on, the people who understand the physics are telling you, in the most restrained way they're allowed to, that the air ahead is about to get rough, and this is the last convenient moment to prepare. And it's getting worse, which is a genuinely under-discussed consequence of a warming planet. As the atmosphere heats unevenly, the jet streams destabilize, and the shear that produces clear air turbulence intensifies. Studies out of the University of Reading found severe clear air turbulence over the North Atlantic increased by roughly 55% between 1979 and 2020. Your future flights are, statistically, going to be bumpier. If you'd rather not experience all of that personally, geometry is on your side. The smoothest seat is over the wing at the aircraft's center of lift, where vertical movement is minimized. The tail is the worst because it sits at the end of a very long lever arm and amplifies every pitch. It's the difference between sitting at the pivot of a seesaw and sitting on the ends. So, the summary. Turbulence is chaotic air produced by heat, terrain, or the invisible seams between fast and slow wind. Pilots avoid what they can and endure what they can, and the machine is built to take far more than it'll ever encounter. The plane was never the problem. You're the delicate instrument in this equation. So wear the belt, sit over the wing, and maybe reconsider ordering the soup.